Now we have a question that is pretty similar to the last question, but what is different is that what's changing is not the payment scheme, but the interest rate. So as always, we start off with another diagram. So this time the payment lasts for 20 years. And then for the first 8 years, we have an interest rate of 5% per annum, so per year. And then for the final 12 years, we have an interest rate of 3% per 6 months. So we're given the semi-annual rate 6%, so the effective rate is 3% per 6 months, per half year. And then the payments are made at 2,000 per annum, but the payments, this is what you receive in total for the entire year, but each payment, but the payment within a year is broken up into 4 parts, so they're done quarterly. So you have 4 separate payments. So they're all going to add up to 2,000. So that means each individual payment is going to be 500. So each one of these small payments is 500. So now we want to find the accumulated value at time 20. So as always, we just break this up into 2 parts. So let's evaluate the accumulated value for the payments from time 0 to time 8. So as always, I don't like to apply those other formulas for calculating the present value or accumulated value. All I'm going to do is just to convert everything to the effective rate, and then just to apply the normal annuity formulas. So now we have quarterly payments, so 4 payments per year. So in a period of 8 years, that translates to 32 payments in total. And there are payments of 500 each. And the interest rate that we're going to use, I'll just call that J. J is equal to 1.05, and then raise it to the power of 1 over 4 minus 1. So 5% is the effective rate for the entire year. Now I'm just chopping it up into 1/4 of the year. So this is the effective rate for 3 months, for a quarter. So all this formula gives us the accumulated value of all the payments from time 0 to time 8 at time 8. So this is the accumulated value at time 8. So we want to bring it to time 20. So we just multiply it by, we just apply this interest rate. So this is a 3% effective per half year, though 12 years in the future. So it translates to, so we just raise it to the power 24. There are 24 periods of 6 months because there are 12 years ahead. So this is the accumulated value for the payments from this section over here. Now we look to the payments at this section. So we just do something very similar. So each one of these payments done quarterly, 500 each. And then there are 12 years in the future, so that translates to 48 payments. So 12 years, 4 each year, so 4 times 12, so this gives you 48. And then the interest rate, we're going to use K for this part. And then K is going to be equal to 1.03 to the power of 1/2 minus 2. And that's because 3% is the effective rate per 6 months. And now we want the effective rate per 3 months, or 3 months, also known as a quarter. So all we have to do is just apply this, and this will give us the effective rate for a quarter, or 3 months. So we just apply this directly into this formula. And then for this expression here, we don't have to multiply it by another factor, because if we take this expression here, it already gives us the accumulated value at time 20. So we don't have to multiply it but by any additional factor. So applying everything into your calculator, plugging in the numbers, you'll get this answer. So this is how you solve this problem. So once again, I don't like using memorizing extra formulas. All I'm doing is just converting everything into the effective rates, and then applying the normal formulas that you're familiar with.